So, in the last video, what I talked about is how to do any old vectors question. So I went through all the kind of basic stuff about how to get around a shape using vectors and all sorts of notation, how to write vectors and all the different rules related to that. So that covered the basics, and all I really want to talk about in this video are the tiny details of how do you deal with bits of vectors using midpoints or fractions or ratios of vectors. They're all different ways of saying bits of vectors. So let's get on with the question. The first thing I want to do is get from O to M. Now you'll notice I kind of missed out all this detail. I'll talk about that in a bit, right? But hopefully most of it you kind of breeze over yourself, like, oh, okay, write the vector in terms of L and N. All these questions, all vector questions, are basically going to say use the vectors that are in the question. Yeah, that's all that means. Anyway, let me get on with it. O to M. O to M. I want to get from there to there. I can take two different routes. I can go this way or I can go that way, and like I said in the previous video, like I explained in the previous video with examples, whichever route you take, it's going to give you the same answer. So I ended up taking this route. No particular reason, just went that way. Up from O to K, K to M, like it says here. O to M, I took the route O to K and K to M. And of course, put a plus sign like you do in these questions. Now, O to K is pretty simple, but K to M, well, O to K is simple because there's a vector going from there to there. It's vector L. That's really easy. But there's no vector going from K to M that you can see already. But what we can do is realize when you work out a bit of a line, like using a midpoint of a line or some other fraction of a line, okay, it's obviously part of a line. So K to M is actually part of a bigger line called K to N. Okay, so that's the kind of thing you have to pay attention to, and you can work out K to N. So that's the general technique. If you've got a bit of a line, look to work out the whole line first and then work out that bit of it. So work out the whole line and say how much is that K to M? Well, that's half of it, so half of the whole line. Okay, let's get on with doing it. So O to K is simply L. From there to there, it follows the vector L in the same direction as L, like the arrow shows. So it's just L, plain old L. And K to M, which it says is half of K to N, is, well, K to N is minus, well, K to N is minus L plus N. Opposite direction of this vector L and the same direction as this vector N. Okay, so to get from K to N, I had to follow the vectors round, like I said in the previous video. The vectors are like train tracks. So if you're a train and you want to get from K to N, you have to follow the train tracks. You can't just go through some field if there's no train tracks there. Anyway, so we're getting minus L plus N is K to N, but K to M is half of K to N, so I'll write half of minus L plus N. Half of minus L plus N, and then you just simplify that just like you do with normal algebra. So this is L plus half of minus L, so L minus half L is half L, and then you do half times N, which is half N, so this just simplifies to that. So you've just worked out O to M. O to M equals half L plus half N. Now if that sounds complicated, let's just quickly go through that really quickly again. O to M is that plus that. That is obviously L, and that is half of this bigger line. With this bigger line, K to N is really easy, is minus L plus N. So it's L plus half of minus L plus N, and that simplifies to this stuff there. Next bit, O to E. So instead of O to M, O to E. It's almost the same thing really. Where is E on this line anyway? It says the ratio KE to EN is 3 to 1. Okay, so KE to E to N is 3 to 1. Okay, so this K to N line is split in this ratio 3 to 1. Now, if you remember how ratios work, that basically means you've got 3 parts out of 4, because 3 plus 1 gives you 4 parts altogether, and so k to e is 3 out of 4, 3/4 of the line k to n, and e to n is 1 out of the 4 pieces, or 1/4 of k to n, just to make that clear, right? So when you got ratios, we're just basically talking about fractions. Even midpoints are fractions of a line. Midpoints is half of a line, right? So let's continue working out the root. And what root did I take this time? I did O to k again. So how did I get to O to e? I could have done this route, go from O to n, n to e, but instead I went O to k, k to e. There's no particular reason. Maybe I just copied the previous example a little bit. Anyway, so I go this way. That bit is just L, and this bit, k to e, is just 3/4 of k to n. Okay, like I just explained a second ago. So k to n, like we said before, is minus L plus n, and k to e is 3/4 of that, so I write 3/4 outside the bracket, and like before, I simplify this stuff. So L plus 3/4 of minus L, so L minus 3/4 L is 1/4 L, and then you've got this 3/4 n left over there, and you've worked it out. So O to E is equal to this stuff. And just to be clear, if I went the other way around, I would have got the same answer, 1/4 L plus 3/4 n. If you got any questions, feel free to ask. By the way, in the YouTube video, just comment.